Hey, hello. So what I'm going to do, we talk about the topics on section 1.4, especially we end up with the inverse the other night, okay? So what I'm going to do, I'm going to continue, give you some examples, application of, operation with the matrix, and which is very similar to the one that you have on your, your practice quiz. And you know that your first quiz is going to be next week. And I post the quiz over the weekend, tomorrow night. And then this is going to be a take-home quiz. And when you're done, you just make a PDF file and just return the solution to the canvas. So let me remind you what we did the other night. And these examples are going to be, very frequently is given to you in this part of the book. Okay, so this is going to be what we did the other night. Okay, I just missed the focus of the camera again. So if you go back, we should get it. Okay, that's it. Remember, I introduced a 2x2 matrix. We talk about the inverse of a matrix, and in case of the 2x2, it's easy to find. That's why you get some problem regarding the 2x2 matrices. Okay, that's one. So this quantity would be defined later on when we get to the section 1.6. So the matrix A is going to be invertible 2x2 if there's a kind of cross product. AD minus BC is not going to be equal to the 0. And if it's a 2x2, easy formula to find the inverse of a matrix. So this is a number like 1/2, 1/3. So what you do is you are going to switch you flip the entries on the main diagonal. That's AD, we make it to the DC, and then you just change the sign of the other entries. So that will be inverse of a 2x2 matrix. Then that would enable us to define a various power. Okay, the zero power of a matrix is 1. There's any other power, you just multiply them together. So if the matrix is going to be invertible, then we can even define the negative powers. So when we have the powers, then we can talk about, a polynomial of matrix if you like. Okay, just like an ordinary function that you have, you can have these type of problems. So you have, for example, a couple of examples in this format. Okay, so I give you this one, which is very similar to one problem on your practice quiz. Okay, so just want to give you the actual one. So this is going to be the one. Okay, so very similar to one that we have. So a matrix would be given to you. You suppose you have a 2x2 matrix. Okay, it's going to be matrix A, which is going to be 2, 0. Okay, 2, 0, 4, 1. Okay, this matrix is given to you, and then they ask you to find. Okay, we want to find the P of A, if you like. P of A, where P is a polynomial of X. Okay, so P of A, when P of X, if you like, when P of X is equal to the X cubed minus 2X plus 4. You have a number of these type of problems. Just want to make sure that you know how to handle these problems. Okay, so basically this is how you're going to think about it. So as a solution, you see it's a polynomial. You can replace the X by a matrix. So this is how we're going to evaluate a polynomial as a matrix. So that gives us A cubed, which is well defined. So we get a matrix A times A times A, and this is going to be minus 2 times A, which is again well defined. But you see for this 4, you have to change this one into the matrix format to be able to do it. So instead of 4, we're going to change it to the 4 times I. Okay, 4 times I. What is I? I is going to be in this case Okay, so I in this case is going to be a 2 by 2 matrix. Okay, remember you cannot write as just plus 4, it doesn't make sense because you have to have a matrices to be able to add them together. Okay, so it's going to be the case. We just remind you that where this I is simply an identity matrix, a 2 by 2 identity matrix. Okay, so you got to be careful when you want to evaluate it. This is the way you're going to do it. So this is a matrix. We are going to find all these quantities to come back and we substitute them with that. Okay, so there you are. We know that A is, this is A 2 0. So I'm going to find the A square first. So the A square would be A times A. So this is going to be 2041. You multiply it by again 2041. Okay, a matrix multiplication. Matrix multiplication, you know that you get the first row multiplied by the first column here. 2 times 2 would be 4. 0 times 4 would be 0. So that gives you 4. You go forward. 2 0 times 0 1. So that gives you all. Okay, this is it. You have 2 0, 2 0, and then 0 1. So this is it. So 2 times 0 would be 0, and 0 times 1 would be 0. So we add them together. We get the 0 0 here. Okay, then we continue. We continue where 4 times 2 would be 8. 8 and 4 would be 12. Okay, then you multiply this one. So that's it. 4 times 0 would be 0. 1 times 1 would be 1. So this is going to be your okay, the matrix that we're going to have. Okay, so we try it again. So that's 2041, 2041. So this one, 2 times 2 would be 4. 0 times 4 would be, okay, would be 0. So we get a 4. So then we continue with this one, 2 times 0, 0, 0 times 1, 0. So it's going to be a squared. Then we're going to find the a cubed. So what's going to be the a cube? A cube would be a times a squared. Would be a times a squared. So we get the matrix, which is a 2041. This is the given one. You multiply by a squared. So the a squared is going to be 4012 1. Okay, so this is going to be the one. So I start multiplying again. If you multiply row column, you see 2 times 4 would be 8. So that gives you 8 only. So this portion over here, this is it. 2 times 0, 0 times 1. So that gives you 0 again. So over here, 4 times 4 would be 16. 16 and 12 would be 28. Okay, that make it to the 28. And over here, that give us 1. Okay, so this is going to be the case. So that's A3. Now we come back and we substitute to get the result. Okay, go to the polynomials. So this is it, your P of A. So P of A is equal to the A cube. This is your A cube. A cube would be 28 1. That's A cube minus 2A, 2 times a matrix A. And the matrix is going to be 2 0. Okay, 2041. And plus 4I is going to be 4 times. The I is 10001. Okay, so this is going to be the result. Okay, it's going to be 8028 1. I multiply the -2 inside, so I put the positive here. Okay, add it, it's going to be -4. You know that you multiply by each entry. So that's going to be the 0, and this is going to be -8 and the -2. So multiply all entries. And this last one is going to be, and that's a 4, 0. You multiply by each one of them, and that make it to the 4. Okay, now we add them together by adding each entries. So what we have is 8, -4, and 4. So that make this one into there. Okay, this is it. Better get this 8 from. Okay, so that was my AQ. So I made it. Yo, that's going to be AQ that I did have. Okay, so that is the 8Q, 8, 0, 12, and 1. So it just double check what I got here. It's 8, yes. That is going to be the case, okay? So we add at the top, that can be 0, and this is going to be 0. And this part, that would be 20, because 20 minus 8 would be 20, and this is a 1. This is going to be -1, -1, and 3. So that give you the final answer over here. Okay, so that is going to be the case that we're going to have. Okay, so this is going to be the matrix in question. So P of A. Okay, so P of A is going to be 0, 0, 20, and 20 and 3. Okay, we can check it again to make sure to get it all right. So similar question. This was given on the test, and some people they missed this one. Remember, it's plus 4i. You get the I, and this is the I. You multiply it, and then you just continue to get your result. Not just plus 4. Doesn't make sense. Okay, so this would give us the polynomials type of the problems. Now, what is going to be other applications so far? The type of problems that you have in your book. And remember, we talked about that we can use this matrix form. If a system of the equation is given to you, we can change it to the matrix form. So I give you an example of this type 2. You have a couple of them in your book. You want to make sure that you know it. So the other example that I'm going to consider is this one. Okay, we want to solve the linear system. Okay, just using matrix inversion, they call it. Okay, there you are. We want to solve the linear system. A linear system using the inverse of a matrix. They call it using the inverse, the matrix inversion. Matrix inversion. That's the way you have it in your book. So the system in question is going to be this one. So the system is a 2x. Okay, 2x plus 9y is equal to the negative 5. Okay, we get the -5, and the other equation is x plus 4y equal to the 7. You see, we talk about it. If you have this system of the equation, you can change it to the matrix form. Okay, so I'm going to change it to the matrix form. So the solution is going to be, we introduce the matrix of the coefficient. We did it the other night. So we call A to be a matrix of the coefficient, which is equal to the 2, 9, 1, and 4. Okay, this is a matrix of the coefficient. And we have the variables, the unknown. We introduce okay, this is going to be the column vector. We get the x and the y. Then you have a constant term. We are going to call it the b, and this is going to be a -5, and 7. Okay, if this is going to be the same, so your system, remember we talked about the other night, so the system would be changing to the a times x. Okay, a times x equal to b. Okay, this is going to be a times x equal to the b. Now we can use the inverse of the a, you see. If you multiply both sides by an inverse, so that gives you inverse of the ax equal to the a inverse b. But the a inverse times a would be identity matrix. So your x is simply A inverse B. You see, that is, we are going to use that type of ideas if the function, if the, okay, if the matrix is going to be invertible. If the matrix is going to be invertible, this is how we can find the solution to the system, okay? A times X is equal to the B. So it's like, you know, in algebra, we have 2x equal to the 5. So we divide by 5, okay? We divide by the coefficient of the X. In the case of the matrices, we don't have the division, but we use the A inverse. So we multiply both sides by A inverse. So this is A inverse times A would be identity matrix I, and the I times X would be X. So that gives X equal to the A inverse times B. So if you want to find the inverse of this matrix, then easily you can solve the equation. Okay, so this is called solving the equation by the using the matrix inversion. Okay, so you have to find the inverse. It's a 2 by 2 matrix, so easily can be found. Okay, so this is going to be a situation we're going to have. So what is the matrix? Okay, so the matrix is A. Okay, this is A, which is going to be 2, 9. Okay, 2, 9, 1, 4. Okay, if you want to find the A inverse, we already talked about it. We find this cross product AD. So what was AD minus BC is a 2 times 4. Okay, 2 times 4 minus 1 times 9. So that make it to the 8 minus 9, which is going to be a negative 1. Okay, so it's not equal to the 0, so the matrix is invertible. So we can find the A inverse. Remember, the A inverse is going to be what? It's going to be 1 over this quantity, and negative 1. We go to the matrix. Remember, we flip the terms, the entries on the main diagonal. So it's going to be 4, and this is going to be 2. We just switch the signs. So this is a negative 1, and this is going to be a negative 9. Okay, that's the result for the 2 by 2 matrix and can be easily found. Okay, so this negative sign, so apply the negative sign. So the matrix would be a negative 4, negative 4, positive 9, and this is going to be 1 and negative 2. Okay, so that would be the inverse of a matrix. Okay, so we have the A inverse. So the A inverse would be a negative 4, 9, and the 1 and negative 2. Okay, so the result, remember, X is A inverse times B. So the A inverse is a negative 4. Then we get the 9 here and the 1 and negative 2. Okay, this is it, times B. B was the constant matrix, which is a negative 5 and 7. Okay, negative 5 and 7. Now multiply them together. When you multiply, this is it. Remember, this is a 2 by 2. And this is going to be a 2 by 1. So the result would be a 2 by 1 matrix. Now how are we going to find it? Just multiply. Row column, negative 4 times negative 5 would be 20. 20, and this is 63, so that will make it to 83. Okay, 83, and the second one, this is it. 1 times negative 5 would be negative 5, and the negative 14 would be negative, okay, negative 19. So there you are. So the X, remember the X was X, Y. And so this is going to be equal to the 83 and the negative 19. So in this case, X is equal to the 83 and the Y is equal to the negative 19. So it's one method, you know, easily can be applied in order to get the solution to the system of the equation. Okay, so if they ask you to use the matrix inversion, this is what they are talking about, okay, to get this system. So we may ask you one of them in your quiz. Okay, so that was the A first system, I give you another one just to practice. Again, you want to solve the system. Okay, solve the system. Again, using using matrix inversion or the matrix form. So the system in question is this one. It's a negative x1. Negative x1 plus 5x2 is equal to 4. Okay, and this is going to be negative x1. Negative x1 minus 3x2. And this is also equal to 1. Okay. So what we are going to do, we change it to the matrix form first. So the solution is going to be, so you are going to suppose the matrix of the coefficient is going to be A is equal to matrix of the coefficient -1, 5, -1, -3. So -1, 5, -1, -3. Okay, this is going to be matrix of the coefficient. A matrix of the unknown is simply x, y, and the matrix of a constant is 4, 1. Okay, so if this is going to be the case, then your system would be ax equal to the b, and we use the inverse of the x, so x would would be a inverse b. Okay, it's like multiplying both sides by a inverse to get this number done. So we have to find the a inverse. So what is going to be a inverse again? Okay, a inverse again, we get that quotient of the AD minus BC, that cross product that we talk about it, is going to be a -1 times a -3 minus, okay, minus 5 times a -1. So this is going to be +3 plus 5. So the result would be 8. 8 is not 0, so the inverse does exist. So, okay, so the A inverse, remember the A inverse is going to be 1 over, this go in future determinant, but not now, is a 1/8. So the matrix, this is it, the matrix. You flip the entries on the main diagonal. So it's going to be -3 and the -1, then switch the signs. This is positive and this is going to be negative. Okay, opposite sign. Change the sign. The one on the diagonal, you flip it, and for the other, you just use the opposite sign. Okay, so we divide by 1/8. So the result is going to be -3/8, -5/8, and this is going to be 1/8, and this is going to be -1/8. So that's going to be your A inverse. Bring it here, get the X. Okay, so what is going to be X? So the X is equal to the A inverse B. So substitute, this is a -3/8, -3/8, -5/8, and you get a 1/8 and the -1/8, and you multiply by the matrix B, the constant, 4, 1, 4, 1. That's it. So if you multiply them together, see, you multiply it, and eventually this is it. -3/8 times 4, -3/8 times 4, then plus -5/8 times 1. To get these numbers, I write it down for you. And this is it, -3/8 times 4. Okay, and this is going to be -5/8, -5/8 times 1. Okay, that's a top entry. And the bottom one is going to be 1/8 times 4. And this is going to be -1/8. This is the entries of a matrix. If you simplify it, so that should give you negative 17 over 8, and the bottom one would be 3, 8. Okay, so the solution of your system, this is it. Your x would be, okay, I write it down over here. So x, or x1, is going to be negative 17 over 8, and the x2 is going to be 3, 8. So that gives you the solution of the system. Okay, so we call it inversion techniques, or the matrix inversion. And that's the kind of application of the inverse so far to get the numbers. Okay, so that will give you an idea of okay, the type of problem that we are going to be interested in this part. So the inverse is quite useful. And now that is when when you have a 2 by 2 matrix. If you have a matrix with a higher size, if you like, there is a method in 1.5. I'll give you a summarizing that method quickly for you, so that we'll be able to do it, okay, because you have a couple of these problems again on that quiz. So we'd like to give you one of them to get to know this system. Okay, it's very, very easy. So what is going to be, how we're going to find, there are different ways to find the inverse of a matrix. We are going to see a couple of more techniques later on, but this techniques is going to be easy, okay, and that's a kind of we just get it by 2 by 2 if you like. So let's see. You can read it for yourself, but I explain the method for you because the method is easy. Explain it. Now, what is that method? This one. This is the only thing that you have to know from 1.5. Okay. So the 1.5 is we want to find the matrix. Okay. So finding the inverse of a matrix in general. Okay, let's say finding, okay, the inverse of a matrix in general. This method, they refer to it as a, this is the only method that you have so far. Okay, the method that we're going to use, we are going to call it inversion method. Okay, what's going to be inversion algorithm. Okay, that's one. Now what's going to be this method? Okay, it can be proved by using just a 2 by 2 one. Now, what's going to be this method? You see, that's a very short method to do it. So, it can be proved, but I just want to give you quickly an example to get the method. You can read the full version from your book. You see, if the way we are going to use this method is, if you give me a 3 by 3 matrix, if I want to find the inverse of a matrix, you know that you have to find another matrix B, so that A times B is going to be equal to the B times A, and the result would be an identity. So you have to find that B. In order to find that B, you can call the B, okay, the entries, some unknowns, x1, x2, x3, and eventually you have to solve a system of the equations. So if you want to solve a system of the equation, you arrive at this short form, if you like. Now, I'm going to explain what is that short form means, and then I'll do it for you. You see, this is the one we call it inversion method. So what's the inversion method? To find, okay, inversion method, to find the inverse, okay, inverse of an of course, invertible. Okay, invertible matrix, invertible matrix A. This is what we're going to do. See, what we are going to do is we are going to using a number of the elementary operation that we do, like the one that we did row echelon form. So what we're going to do is we are going to use some some elementary operations we apply to this matrix A to change it into the identity matrix. Identity matrix. Remember identity matrix? If it's going to be 2 by 2, it's get 1, 0, 0, 1. If it's going to be 3 by 3, 1, 0, 0, 0, 0, okay, 0, 1, 0, 0, 0, 1. So we are going to pick A in one side, identity matrix on the other side. You see, we put them together. So what we're going to do, we start working on this one. We do some elementary row operation in order to change the A into the row echelon form. But we change it into the, okay, eventually we change it to the identity matrix. At the same time, we do the same operation to the identity matrix. So when we get to the end, this part is going to be identity matrix. So whatever you have on the second part, that would be your A inverse. It's like if you want to solve a system of the equation in order to get it. Okay, so put the given matrix on one side and identity matrix on the other side. Start converting the given matrix into the row echelon form so that this black one, the A, would be changed into identity matrix. At the same time, you're doing operation to the other one, same operation. So at the end, you start with the A and I. At the end, okay, it would be switched. This would be I, but the leftover would be A inverse, and then you're done. Very easy operation. Very good one. We are going to have another method, but this method is the easiest one. We usually use this one. Okay, so there you are. To find the inverse of an invertible matrix A, this is what you're going to do. You are going to find a sequence. Okay, find a sequence of elementary okay, row operation, elementary row operations that make A, okay, that reduces the matrix A to the identity matrix, to the identity matrix, matrix I. So if A is a 3 by 3 matrix, your I would be 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, and then what you're going to do, you see, and then the same operation, then perform. Okay, then perform that same operation to the identity matrix, that same operations, okay, on I, the identity matrix, to obtain A inverse. Obtain A inverse. Okay, so you reduce the A into the identity matrix by some elementary row operations. But whatever you do, at the same time, you do it to the I. So you convert the A into the I, so you convert the I into the A inverse, and then you're done. Okay, so this method is called inversion method. Inversion method, okay? So this is what would happen. You start with the A, this is the matrix A. Okay, and this is the matrix I. So you do the operation, you switch it into, you do the operation to switch this one into the I. So you do the same thing to the I. So this would be A inverse. You see, this is the way we do it. Very easy method. Okay, so we call it inversion method. And for the time being, you don't have any other method, so you have to use this one. So we give you one on the quiz. Okay, there you are. And you have 3 on your practice quiz. Example, that's it. Find the inverse. Okay, find the inverse of a matrix. We don't have to give you a method because you don't have any other choice for the time being. Okay. Okay, if you like, I'm going to using inversion method. Inversion method, if you like. But you don't have to be told because you don't have other choice. Okay, there you are. So the matrix is this one. Matrix 1, 2, 3. 2, 5, 3. 1, 0, 8. That's it. Okay, so you want to find the A inverse. Okay, you want to find the A inverse. So this is how we are going to go to get that number done. Okay, are you ready? So this is it. To give another one, but okay, that's fine. I go with this one to see how we're going to make it. So solution. This is how we're going to start. You see, this is the given one. So this is going to be, I'm going to start with this one. You see, you're going to get A and I in this format. Okay, so this is your A, 1, 2, 3, that's the first row. And that's a 2, 5, 3. And this is 1, 0, 8. Now bring the identity matrix, see, 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. So this is A and this is I. Work on this one. Change the first one into the identity. You have to do row operations. So you do the same thing to the second part. So if you get the first one to be I, the second one would be the inverse, and then you're done. Okay. So go for it. So the first step, you need a 1. You already got the 1. So you have to change this into the 0. Okay, you know what to do. And to change this one into the 0, the row operation is going to be what? And this is R2. We change it to the R2 minus 2R1. And this would be R3. We change it to the R3 minus R1. Okay, let's do it. So what's going to be the result? So the first one is unchanged, 1, 2, 3. Okay, 1, 2, 3, and this is going to be 1, 0, 0. R2 minus 2, R1, 2, R1. 2 minus 2, negative 2 would be 0. Okay, this is 5, negative 4 would be 1. Okay, this is 3, negative 6. Okay, that gives me negative 3. You do the same thing here. This is 0 minus 2R1, that gives you a negative 2. Okay, and this is it. 2R1, and that's going to be 0, and this is going to be 0. Okay, so you do whatever you do the full matrix. R3 minus R1, you subtract 0. R3 minus R1, that's a negative 2. R3 minus R1, that gives you a 5. Okay, R3 minus R1, that gives you a negative 1. And R3 minus R1, which is 0. And R3 minus R1, that gives you 1. So that gives you the matrix. Okay, we are done with the first row. We got the 1 here. Now the second one, we already got the 1. So you have to change these two to the 0. Okay, so this is the way we're going to do it. So I can, this is the R1. I can check the R1 plus R3. You see R1 plus R3, that give me 0 here. Okay, to make a 0 here, I can multiply this one by 2 and add it. So this is going to be R3. I'm going to get the R3 plus 2R2. Okay, to make those 0. So it's going to be the conclusion. The first one, R1 and R3. So we add them together. It's going to be 1, R3, 0. Okay, R3, 8, R3, 0, R1 and R3, 0, and R1 and R3, that give me 1. Okay, the second one is going to be unchanged, 0, 1, negative 3, negative 2, 1, 0, R3 to R1. Okay, this is it, 2 R2. 2 R2, negative 6, that could be a negative 1 here. Okay, that's it. 2, negative 4. Negative 4, that give me negative 3 here. Okay, 2, that give you 2. And this is going to be, okay, let's see if I missed anything. So that would be 0, and this is 2R. So that's a 0, okay? That's 0. So the second one is 2R2. Okay, that's it, 2R2. So this would be 0, 2. Okay, this would be 0. So 2R2, that would be negative 1. I just switch, That's a negative 1. That would be negative, okay, 2R2. Okay, so that give me negative 4, which is, this is going to be negative, that's a negative 4, and that give me negative 5. Okay, negative 5, and that is going to be 2, and this is going to be 1. Okay, so we are almost there. This is it. So I got the 1, 0, 0. I got the 0 here. So I have to take care of the last one. I need the 1 here. Okay, I need the 1 here and 0, 0 for the others. So what I'm going to do is I multiply this one by negative 1. So this is R3. I change it to the negative R3 to get the 1. Then I have to get rid of these. Okay, so this is R2. So I change it to the R2. I need the positive 3. Minus 3R3. Then I get rid of this one by, again, I have the R1. I change it to the R1, okay, plus 8R3. So that give me all I need. Okay, remember you have 1, 0, 0, 0, 1, 0. So you need to you have 0, 0, 1. Then the leftover would be what you are looking for. Okay, so let's do it. So what's going to be the next part? Okay, the next part, R1 plus 8R3. This is it, 8R3. So 8R3, that make it to the 1. This is going to be 0. Okay. And 8R3, 8 and 8 would be 0. That's what we are looking for. 8R3, that would be negative 40. Okay, because 8 times negative 5 would be negative. Okay, 8 times 2 would be 16, so that make it to the 16. 8R3, 8 times 1, 1, that make it to the 9. So that would be the first row. The second row, R2 minus 3R3. So we get a 0 here. Okay, we get the 1 here, 3R3. You see this is a negative 3, and this would be 0. And a negative 3, negative would be a positive 15, 13. Okay, so I check it again. This is negative 3R3. 3R3, that gives us a positive 15. Okay, negative 3 times negative 5 would be, so that give you 13. Okay, so that give you 13. So we continue this one, that gives us a negative 6. Negative 6 made to the negative 5. Negative 5, negative R3, that gives us a negative 3. That's a negative 3. Okay, and the switch sign here, so it's going to be 0, 0, 1, 5, -2, and -1. There you are. You see? So you change the first part into the identity. So the second part would be A inverse. Okay, so as soon as you get the first one, which is going to be identity, so this is going to be, just switch the first one to the identity, so the second one is A inverse. So officially, it's a very nice method. So officially, this is going to be your A inverse. A inverse, -40, -40, 16, and 9. And then we get the 13, -5, -3. And this is going to be 5, -2, -1. Nice matrix. Okay, this is called inversion method. That's a method that mostly we are okay. Most of the time we are going to use. So you must know it to get this number. Okay. Now we need one more example to finish it. Sometimes you'll be surprised. The question is, you know that not all the matrices are going to be invertible. So when or how are you going to find out? It's not the case that always you get a solution. So how are you going to find out? The next example will tell you. Okay. So that's example 1. You need 2. Okay. Sometimes it may be impossible to get to the, okay, to convert a matrix A into a identity matrix. If you cannot do it, this means this matrix is not invertible. So you must have this second one. Okay, so how about this one? The matrix A is going to be equal to, that's it, 1, 2, 0. 1, 2, 0, 3, -1, 2. Okay, and the -2, -2, 3, -2. Let's see what is special about this one. Okay, so we want to find the inverse of this matrix. Inverse of this matrix and using the just inversion method. Okay, there you are. Solution. So what is going to be the solution? So we start with this matrix. We form the matrix A and the matrix I. You put them together. So this is it. So your matrix is going to be 1, 2, 0, 3, -1, 2. Okay, and this is going to be -2, 3, and -2. Oh, I'm sorry. This is, I should write there. Suppose this is dot, dot, dot. So I put the I here, 1, 0, 0, 0, 1, 0, 0, 0, 0. Okay, there you are. So this is A, this is A, this is I. Okay, now we have to change it. We try to change the first one into the I, and the second one would be A inverse, if we can. We already got the 1, so we have to change this into the 0. So what to do is R2, so it's going to be R2 minus, you need the -3, minus 3R1. Over here, this is going to be R2, you need the +2. So it's going to be R2, I'm sorry, that's R3. So that's R3 is going to be R3 what? That was a 3, R3 plus 2, plus 2R1. Okay, so get it done. So the first one is going to be unchanged. So it's going to be 1, 2, 0, and this is 1, 0, 0. Okay, that's the first one. The second one, R2 minus 3R1. 3 minus 3 would be 0. 3R1, 1 minus -6, which is going to be -7. Okay, and this is it, R2 minus 3R1, that's 0. Here are 3R1 that give a -3. R2 minus 3R1, this is just 1. This would be 0. Okay, next one, R3 plus 2R1. This is it. This is a negative 2 to R1. That give you positive 2 is 0. And 3 to R1, 2 times 2, 4, 7. Okay, and here, negative 2, and that give you a negative 2. Okay, over here, R3 to R1, that is going to be 0, and 2R1, that give you 2. Okay, that's a 0, 0, and that would be 0, 0. Okay, so there you are. So this is what you are going to end up. Okay, so what next? So we already got the 0, 0 here. So we have to take care of the second part, okay? You have to change this one into a positive 1 to be able to do it. But have a look at this, okay? Look at these two that we have. Okay, I double check this one. So that was R2 minus 3R1. So that make it to the 0. 3R1, that give me negative 7. So that's it. That is a negative 7. And then I got here R2, my R2 is 2. I missed this one, you see. R2 minus 3R1. So that's also 2. And that make it interesting. Look at this one. Look at these two rows together. So if you add the R2 and the R3 together, what's going to be the result? Okay, if you get the R2, which is going to be R2 plus R3. Okay, if you do it, the result would be surprising. So it's going to be 1, 2, 0. Okay, 1, 0, 0. And when you add these two together, that gives you 0. This would be 0, and this would be 0. Okay, we get a 0, 0, 0 over here. And over here, the leftover is going to be just what? This is R2 plus R3. So that gives you a negative 1, 1, and a 0. And the last one is going to be 0, 7, negative 2, 2, 0, 0. You see, look at what you got over here. You see, the difficulty is this one. Look at this one. Remember this operation, you have to change the first part. A is to the identity. When you get one row to be 0, 0, 0, you cannot continue. It's impossible, because for the identity matrix, you know that this must be 1. And since you get the 0, 0, 0, it's impossible to go on. So it would be impossible to change the first one into the identity matrix. So you stop and you claim that A inverse does not exist. Okay, so this will tell you that A is not invertible. Not invertible. Okay, so this may happen. So you got to be careful, because this procedure would give you a positive answer if you can change the first part into the identity matrix. So if one row happened to be 0, 0, 0, it's impossible. It's impossible to create the one over here, okay? So in that case, it's not possible. You stop and the matrix is not going to be invertible, okay? Otherwise, it's a nice method and give you the result. So be careful. We give you one on the test, on this quiz, using, inversion method. Using inversion method to get the result. For the 2 by 2, you can use the same method if you like, but we give it that shortcut, short formula to be able to do it. So that's it. We are ready for the quiz. I'll give you more examples later, but I just wanted to give you this one so that you'll be able to solve all the problems on the coming quiz. Okay. In future, when we start with the 1.6, there is going to be another method to find the inverse of a matrix, but this is the easiest one. So we use it quite a lot in this course, okay? So nicely write it down, and using those elementary row operation to reduce the matrix A into the identity matrix, So the leftover is going to be, okay, the leftover is going to be your A inverse. The proof, it's very much involved, but you can do it for 2 by 2 to prove it. And you know, it's in your book. If you like, you can read it, but we don't need it. The application is very important for us. Okay, so have a good one. So you are ready for it over the weekend. You should be able, I check, I may post again something for you just regarding that practice quiz. But if you have any question on that practice quiz, you can email me and I may post a solution to that practice quiz. I'm not going to record anything for that. So we are done with the second week and we are up to the 1.5. So we give you the quiz as a take-home quiz. Okay, I post the quiz tomorrow night for you. If you have any question over the weekend, you can email me. Even we can set up a Zoom meeting if you know if it's needed. I don't mind. Okay, take care and have a good one. Bye bye.